So when we happen to discuss about universal law of gravity, so let me start off with this. So you have an object, you have one more object. They can be of any mass and at any distance. Sorry, not 1 meter, r. Then the force of attraction between them is given by, or is proportional to, the product of the mass and inversely proportional to square of the distance. And when we remove this proportionality symbol, you get a proportionality constant. And this is what we are trying to understand now. That's your gravitational constant. Gravitational constant. That's the name given to that. So if we have to figure this out, at least numerically, or to define it, how can we do it? So let me ask you guys this way. In all of this expression, what can I control? In all of that expression, what can I control? Its definition and value, honestly. This is how you can figure it out. Yeah. Value we'll do it later. Okay, let me do that later. Let's just try to define it. So my question to you guys is simple again. In all of this, what can you control? You can't control F, at least not directly. G is a constant that you can't control. Mass can be controlled. Yeah, mass of two objects. I can take two objects which of, say, of 2 kg and 3 kg. I can control that. R can I control? Yes. How far they are apart, I can control that. Say I take an object of, say, what is the best value to take so that all of this calculation becomes easy? Correct, 1 kg. So I take two objects which are of a kg mass each, kept at a distance of how much? Ideally it would be, yes, 1 meter. That would help. This being the case, the math, therefore F will be equal to G times of 1 by 1 into 1 by 1. So technically F will be equal to G. Agree? So with this in mind, can I define G now? So the value of G or G can be numerically equated to gravitational force or force of attraction. Force of attraction between two bodies of, in this case we are looking at unit mass each, right? And they are placed unit distance away or apart, right? G can be numerically, yeah, it can be numerically equated to the force of attraction, right? Perfect. So we can do this. So this is one of the way of defining G. And this is how we'll find the value of G also, using something like this. Next, unit of G. So we have F is equal to Newton. This is a meter square and this is kg square. Newton meter square by kg square. That will be your unit. Okay, anything else? Note is universal constant. G is universal constant as the value of G. Okay, this is a universal constant. As the value of G does not depend on the nature, size of the object or on the nature of the medium between the two objects. That's why it's a universal constant. That's one small note. So in the next video, we'll be looking at how one was able to figure out the value of G, or how one can figure out the value of G.